So this trivia question says, name the first general purpose mobile robot able to reason about its own actions. If you think it is A, roamer, make a lot of noise. Oh no, these are too easy for you. If you think it's B, shaky, make a lot of noise. Okay. If you think it's C, trucker, make a lot of noise. Okay. So I think the winner is shaky as far as noise goes. Yes, and that is the right answer. So shaky was developed at SRI just up the road. You can see it at the Computer History Museum in Mountain View, though you all probably knew that because these questions were too easy. Okay, so I talked a little bit earlier about our research programs and our industry programs. Another important audience for HAI is policymakers and civil society. So HAI's policy and civil society team drive key conversations around the responsible development, application, and governance of AI through cutting-edge, multidisciplinary research and tailored education programs. And so that leaders in that space can learn to craft informed, effective policies to foster innovation, thinking about societal needs. So AI is not just a technological issue, it's touching many aspects of our life, from healthcare to education to economics, law, and more. And so a multidisciplinary approach helps us think about these complexities. And our final panel, Societal Impacts of Robots in a Human-Centered World, aims to discuss how robots can be designed in a responsible way, considering their impact on various aspects of our lives, different demographic groups, how it impacts our well-being, our social interactions, national security, and more. And to moderate the panel, I would like to invite Allison Okamura up to the stage. She is one of the co-organizers of this event. You have seen her earlier, but for completeness, I will introduce her. She is the Richard Wieland Professor of Engineering at Stanford University in the Department of Mechanical Engineering, courtesy appointment in computer science. She's HAI-affiliated faculty and also on the executive committee for the Stanford Robotics Center. Welcome, Allison.
Let me invite all the panelists for this next session to come on up, and I'll do introductions. So to finish out our day, we have a somewhat purposefully eclectic panel to really bring in some different perspectives towards this issue of societal impact. And hopefully this will bring together many of the technical topics we talked about today towards what does this mean for our future. So I'm going to start by first giving an introduction, short introduction to each of our panelists, and then we'll start kicking off with some questions, and then we'll have some time at the end, I hope, for questions from the audience. So let me start with Steffi Paepcke, just to my right. She's spent her career integrating human-centered design process with the field of robotics, building on her master's in human-computer interaction from Carnegie Mellon University and a bachelor's in psychology from UC Santa Cruz. She's a senior manager of robotics user experience, or UX, team at Toyota Research Institute here in the Bay Area. And she's responsible for bridging the gap between the engineers who build TRI's robots and the people who ultimately use them. And then to Steffi's right is Londa Schiebinger. Londa is the John L. Hinds Professor of History of Science in the History Department here at Stanford. And she's director of the EU and US Gendered Innovations in Science, Health, and Medicine, Engineering, and Environment Project. And she served as director of Stanford's Clayman Institute for Gender Research, and she's a member of the American Academy of Arts and Sciences. And a personal note, I love, Londa, receiving your weekly email with reviews of the literature related to gendered innovations, which is always very, very thought-provoking. And next we have Steve Collins. Steve is associate professor in my department, the Department of Mechanical Engineering here at Stanford. And his primary focus is on speeding and systematizing the design and prescription of prostheses and exoskeletons by using versatile device emulator hardware and human-in-the-loop optimization algorithms. He's on the editorial board of the journal Science Robotics and has won international awards for his contributions to medical robotics. And last in this eclectic group is Amy Zegart. Amy's the Morris Arnold and Nona Jean Cox Senior Fellow at the Hoover Institution a senior fellow at the Freeman Spogli Institute for International Studies and HAI, and she's professor of political science by courtesy all here at Stanford. She's the author of 5 books and is an internationally recognized expert in US intelligence, emerging technologies, and global political risk management. And so I hope you'll see that this panel will come with lots of different perspectives on the issue of the future of robotics in society. And so I'd like to kick this off by trying to think about the societal impact of robotics from the different lenses, the different perspectives that each of you bring in your different roles and backgrounds. So what I'd like to kick this off with is each of you spend a few minutes talking about what do you think is a really important societal impact of robotics that will happen in the next 10 years? And do you see it as a positive or a negative, or maybe both? And again, I'd really love to see this through the lens of your individual background and how you bring that to the table. So why don't we start with Steffi and we can go down the line.
I knew I shouldn't have sat right next to you. Fine. So I am really focused in my work on manufacturing robotics, and in the past I spent quite a long time doing a lot of in-home research with older adults. So that's sort of those are the 2 contexts in which I operate mostly. I think on the kind of manufacturing side, or overall, I think the biggest shift will just be in who does what type of work, or who or what does what type of work. In manufacturing, there are a lot of opportunities to continue doing what we've been talking about, maybe not me personally, but for decades, these dirty, dull, dangerous tasks that will continue to happen, where robots, as they become more capable, take on the tasks that really are not healthy for the human body. But in addition, robots will play more of the role of a tool that people can teach to do the tasks that they would prefer not to do, so they can focus more on the activities that really require a human touch and the things that humans are really good at. So things that require some level of emotional intelligence, also supervisory roles will be more the focus of folks in the manufacturing environment. But also, if you're putting thousands of robots into manufacturing facilities, they're going to require maintenance. There's a ton of work that's going to need to happen for upkeep of the robotic systems. So I think people will slowly, maybe not in the 10 years, but further out, move more into the role of an orchestrator of robotic systems. And then on the home side, and I think this is more than 10 years out for sure, there are a lot of opportunities to offload, so in caregiving, offloading the very physically demanding tasks so that caregivers can focus again on the elements of their work that really benefit from human-to-human contact. There's just going to be a lot more space, I hope, for people to do the things that really require the elements that make us human, and the emotional intelligence aspect of it. So I think, again, that's a ways out, and all of that has to happen with a lot of care, because the home environment is a very private and intimate place. So you can't just dump a robot in a home. There's a lot of work you need to do leading up to a successful deployment of a robot. Yes.
Great, thank you. Londa, can you take it?
Well, I've been waiting for years for a robot to clean up my kitchen. And I've seen some around, but it seems like we really are far from that. However, as we bring humanoid robots into our homes or into our nursing homes or hospitals, we have to think about what social characteristics we're embodying in those robots. And to take Rodney's cue this morning, are we gendering them? And sometimes gendering robots is really helpful. Say you have a nursing robot. Well, we know that 90% of nurses in the US and globally are women. So do you build that robot to users' expectations, i.e. gender it more or less as a woman? That might make the patient more compliant. They might be more willing to take the medications the robot is suggesting or do the exercises. But there's a danger here. As soon as we start gendering robots or building ethnicity or adding skin tone, we are reinforcing stereotypes. Those social stereotypes that Maya was talking about get built into the robot, and stereotypes also embody social inequalities, and if we build those into hardware, therefore hardening them, we could amplify those inequalities into the future. So say instead of embodying the stereotype in the nursing robot, we went against the stereotype. We asked people to think about that stereotype. So we gendered it as a man. That might allow more men into the profession of nursing, which is often a very good job, and therefore open people's minds to the possibilities of changing society in ways that promote social equality. So I think roboticists' job is to understand what genders a robot. We're very good at reading cues, social cues, almost immediately. I had roomfuls of students and I asked them, well, does your Roomba have a gender? And you would be surprised the stories I heard. They almost all had names, which genders them immediately, that sort of thing. So I really think that roboticists need to understand how gender or ethnicity or other social characteristics are built into robots, and then to design their robots to promote social equality. So building off of what Fei said this morning, HAI's goal and the Robotics Center goal is to do good in society. So we want to create hardware, robotics that will promote equality.
Steve.
Sure. So let me start by taking a risk by commenting on something that's a little out of my personal area of expertise and talk about robots in industry and commercial settings and replacing labor, and also the risk of saying something that's not entirely positive at a robotics workshop.
We've blown past that, Steve. We've done that already today.
I think it's true that we should see a reduction in the dull, dirty, and dangerous jobs done by humans and an increase in productivity, but I think we should be realistic about the negative consequences in terms of concentration of wealth and resource control, and the continued increasing disruption and economic marginalization of people whose incomes derive from labor, and with the political and social consequences that can occur as a result. And maybe we should really be thinking a lot about how we more fairly distribute the products of robot labor as it constitutes a larger portion of labor across the country. But my own little more comfortable, closer to home area of expertise, I think in the next decade we will see big improvements in physical human-robot interaction, and there is a great potential for improvements in human quality of life as a result of those changes, partly driven by AI and partly driven by better understanding of humans. And I think that'll mostly happen in fairly constrained domains still. These very general human-robot interaction problem, it's extremely hard, and I think it faces some of the same problems as we see in, say, self-driving cars, where our risk tolerance is quite low, and it will take a long time to get tools that are reliable enough to, say, put in our homes and take care of us. But in some domains, like, say, surgical robots, we can continue to see new surgeries, safer, less invasive, maybe lower cost, and in the wearable robots that we develop in our lab, I think we are poised to see more of these devices out in the real world, improving access to society, especially for people with disabilities and people who are experiencing mobility impairments as a result of aging. Of course, there is also a potential downside that we have to watch out for with improved physical human-robot interaction. These same technologies could be used to increase our social isolation and to continue to mediate and monetize human-to-human interactions. And that's something we need to be mindful of and try to steer clear of.
Okay, great. And Amy.
So Allison, I'm aware very much of the fact this is the last panel of the day. I'm a Z. I'm usually last. I'm the last speaker. And I'm talking about war. So I think my role here today is to drive everyone to the bar immediately after that. So in the realm of international security, I think robotics is poised to transform how wars are prevented, how wars are fought, how wars are won. Why do I say prevented, fought, and won? The things go together. So military capabilities, whether they're robotic, unmanned aircraft or not, any military capability helps you in diplomacy because it gives you leverage in a negotiation. So why do we have so many military capabilities and people in Seoul? To protect the Korean Peninsula, right? Why do we have so many people stationed in Germany? To keep the Soviets and now the Russians from attacking NATO. So any capability that's a weapon is also a help in diplomacy. So prevention goes hand in hand with war fighting. That's something that most people don't think a lot about. We talk about deterrence. You can't deter unless you have capabilities. By the way, I heard a lot of references to kids today. All parents are deterrence experts. They just don't realize it. So what we're seeing in 10 years is actually happening today. And the biggest laboratory for robotics and warfare isn't on a university campus and it's not in the Pentagon. It's called Ukraine. 1 million people are estimated to have been killed or wounded in Russia and Ukraine in this war in 3 years. And currently the best estimates are 70% of those casualties are caused by drones. Drones are estimated, again, it's unclassified based on open source intelligence, are estimated to account for more destruction of armored vehicles in this war than all other traditional weapons combined. Ukraine has waged war against Russia's far superior navy, denied control of the Black Sea, destroyed 24 ships without its own navy because of unmanned systems that they have developed on the fly. So we are seeing rapid prototyping and experimentation with unmanned systems on the ground, in the water, and in the air in Ukraine. And there's no going back from that. Now, what does that mean? In national security, it's all good news, bad news. It's both, right? On the one hand, the advent of robotics could dramatically reduce the risk of loss of life. Warfighters on the ground and non-combatants that are in the way, because robots don't feel fear and they don't fire in anger and they don't get tired. And armed with AI, they're often better at item recognition. So is that a bad guy with a rifle or a good guy with a rake, right? So algorithms are often much better at identifying the difference between a civilian and a combatant than humans are. So there could be dramatic reduced risk to human lives the more that we use robots in war. Robots could decrease the cost of defense. That could also then enable more budget to go to things that we all really care about in our society. And they could reduce the prevalence of war because they could enhance deterrence in new ways, and we can get into that if you want. But the flip side, of course, is there are profound ethical challenges raised by any new technology, and robotics is no different. What's permissible with an unmanned system? What's accountable for an unmanned system? How do we think about human judgment in the role that it plays? So lots of questions about raised by the creation of these systems. Oh, and by the way, authoritarian regimes are likely to use these same technologies very differently than democratic regimes will, because democratic militaries trust their soldiers and decentralize authority, whereas authoritarian regimes do not trust their soldiers. They don't want to have a coup. And so you can imagine much more permissive controls of robots replacing humans and the decision-making in authoritarian regimes than in democratic countries.
Great, thanks. Let me have you start actually next, Amy, because I want to build a little bit on the discussion that you're having about warfighting and robots. You know, it's truly field robots, right? You know, outside the home, very different from many of the discussions today have been around robots in the home. I'm curious what vision you have for dual use activities of robotics. So when we were in DC back in February and talked to a number of folks in Washington who were very interested in the topic of dual use technologies and robotics, since many of the researchers and companies here are working towards domestic and manufacturing, and you know, you're concerned about the large, you know, geopolitical applications. Are there any interesting connections or intersections you see there, things that we should be worried about in that space?
So I often joke that, my wonderful colleagues in engineering see everything as a great possibility, and I see everything as a weapon. So that really amazing robotic dog outside apparently did hold a rifle at one point. It's true.
Yeah.
Right, dual use is inherently very useful for commercial purposes and also can be used for nefarious purposes by adversaries. So the obvious risk in robotics is cyber vulnerabilities. Anything that's smart is also vulnerable. And we've seen large-scale cyber attacks using HVAC systems, right? Using you name it, right? So your baby monitor can be used. So the more that we have things that are connected, the more we have things that are vulnerable. That's sort of point one. Point two is there are always unintended use cases for every technological innovation. We originally thought that social media was liberation technology, remember that? Enabling people to come together to protest authoritarian regimes. Now it's become repressive technology, right? In a lot of ways, or polarizing technology. Mm-hmm. So there are always unintended consequences. And I think the challenge for us, the challenge for inventors and the challenge for investors and the challenge for policymakers is to try to mitigate those risks, to think as much as we can ahead of time, what are the good things that we want to get out of these amazing technologies, and how do we mitigate the risks that they'll be used in ways that we don't intend or want?
Great, thank you. So let's go then, with that concern about these technologies that are in our home, even the baby monitors, which I had not thought about previously. Steve, you're very interested in prostheses and exoskeletons and devices that are sort of very intimately connected to the human body. How do you think about safety? What kinds of maybe misconceptions do people have? What would you want to tell people about these types of devices?
Sure. Let me just very quickly build on what you just said. I think it's a fundamental problem that we face is that technology is advancing very quickly and at an accelerating pace, and our firmware is not keeping up, and hardware, and our culture is not able to adapt as fast, and our government, and so that is a fundamental risk of extremely fast technological development. But let's talk about wearable robots for a second. That's nice. Yes, it's an interesting moment in this kind of technology. We're starting to finally see some devices that can meaningfully improve some aspects of performance and some tasks for people. And we have some basic tools for automatic customization of assistance to an individual person's needs, which are very promising, like human-in-loop optimization. At the same time, we are not yet able to assist all aspects of performance that people care about or across all the tasks you'd want to assist with a given device. And I think that's evidenced by the fact that there are no wildly successful wearable robot products yet. I think one of the big challenges that maybe is misunderstood in this domain is that the most difficult thing in that system is not the robot, but the person. Humans are just incredibly mind-bogglingly complex, especially in our nervous systems. It makes us extremely hard to predict. And the physical interaction with a human is a very complex phenomenon. So we don't have good predictive models that we can use to develop our expectations for some new device we've dreamt up. And that really slows us down. Now, AI is poised to help us with, to solve that problem. However, it requires a large amount of data. And we simply don't have the volume or type of data that we really need to develop those kinds of predictive models. As I say, these physical interactions are very complex, and it's almost none of that information is contained in, say, a video of a person interacting with a robot. And so if we want to bring AI tools to bear on this problem, we'll need to develop ways of collecting large amounts of data from which we can learn. Another challenge is that people are already quite good at the things that we choose to do. Our standard of success is very, very high for these devices. And so it has to really improve your performance to outweigh the nuisance of physically putting something onto your body and the weight of the thing. And you imagine for an older adult how much faster or easier or more stable does walking have to be to justify that bit of weight, or being a little sweaty where the thing touches your body, or having a little bit bigger midsection where the device sticks out? It's quite a tough trade-off.
Right. Yeah. Thank you, Steve. I'm going to go to Londa next. So I've participated, for example, I know Maya Matra did as well, in a workshop you had about gendered robotics, and that was fascinating. It was definitely eye-opening for me at the time. So you gave advice earlier that the robot designers in our audience should really think about this. I think people are always telling engineers that they should do more ethics training or learn about these other topics. What advice do you have for our field about how to teach this, and when is that appropriate, and what are the ways in which we make people aware of maybe unintended consequences of design decisions?
That's a great question. Can I ask Steve a question first?
Yes, absolutely, please.
So, well, I'm interested in, for these wearables, are there any sex differences you need to consider, or is it all personalized? And is there anything having to do with skin tone or other characteristics? Because we learned during the pandemic that pulse oximeters, something so basic as pulse oximeters, don't work for people with darker skin. People got themselves to the emergency room, but the pulse oximeter confused melanin in the skin with hemoglobin in the blood, and therefore gave higher readings than were true. And the people who needed supplemental oxygen at the time didn't get it. So I'm wondering, like for exoskeletons, there are differences in the male-female pelvis. I mean, what of this is important?
Oh, no, that's very important. There are average differences based on genetics between populations, and every individual is very different. And it turns out that finding what an individual person needs from their device is essential to getting the best performance out of it. Maybe you double the improvements in these performance metrics by customizing to a person. And certainly the fit and feel of a device, it really depends on your body shape. And there's also the question of the kinds of problems that we try to take on and how those interact with gender. For example, I've had a few of my PhD students had children while working in the lab, and an idea that we've workshopped but haven't actually attempted yet is a pregzoskeleton. To try to alleviate that.
Haven't heard of that. Cool.
It's being pregnant's hard. And so devices that are specifically designed to help with the additional physical load on the body, that results from pregnancy. But, yeah.
Cool. Well, to get back to Allison's question, I wouldn't try to tell roboticists what to do because you're brilliant people, and I've worked with a number of you. I really enjoyed the workshop. Maya and you were there, and then Monroe, who just gave the talk before, was at a workshop, NSF-funded workshop that we did on domestic robots, and how does the dynamic of the family change when you introduce a robot? So really interesting. I think one of the most interesting things that came out of that workshop was that I don't think it was Monroe's work, but somebody who was at the workshop, they had been filming apartments and living spaces so that they could work on robot navigation in domestic settings, and they realized that every film they had, the person had a swimming pool, meaning that they had only done one socioeconomic group, wealthy, large homes, and not cluttered student apartments or something like that. So there are often elements, there are things that people might want to consider and just haven't thought of. So I think there has been a move now, and the National Academies of Sciences did a really great report about a year or two ago on responsible computing, and we could use the same for responsible robotics. And there the suggestion is the embedded ethics model for CS, which could be used also for robotics, that as you're teaching the technical courses, you're also pairing that. This started at Harvard with the computer scientists, Barbara Gross, and then a colleague of hers in philosophy. And they taught these courses together, teaching both the technology and potential social impacts at the same time, meaning that the students would get some information about gender, domestic setups, various social issues, and how your technology might reinforce or improve those sorts of things. So I think, now this is what a university is supposed to do, right? Stanford teaches everything, and for the first 2 years, we require students to take a broad menu of things, from humanities to social sciences to hard science and engineering, that sort of thing. But people tend to stay in their silos. So I think that we really need to do more of this dual teaching. And it could be, I think we should start it at the undergraduate level and really go into it, the master's and PhD level. And I'm happy to help.
Thanks. Yes, and Stanford is the perfect place to try to implement such things. Steffi, I wanted to ask you from the perspective of someone who's in industry, and a lot of the discussion about robotics today, again, was about robots going into the home and helping people. What is your feeling about business-to-business applications of robots versus robots straight to consumers? How much more difficult is the latter? Mm-hmm. And what do you think is the goal of that will be most successful for companies in the current climate?
Mm-hmm. So for me, when I'm on a project, it doesn't really matter if it's going to be a robot that's in a factory or a robot that's going to be in a home. The process always starts the same. And people, over the course of the day, kind of described it, but without really naming it as the user-centered design process. Maybe Wendy said it. And this is really the core of the work that my team does. Going into whatever environment you're going to be designing a robot for, and going in with a tech-agnostic mindset. That is very important. You're not coming in with the really cool robot that you spend a lot of time building and looking for a problem. That's where I think a lot of things kind of go awry right from the beginning. And I understand I'm in a very comfortable position at TRI where we have the resources to do that. It's a little startup, it's more challenging. But ideally, you're following the user-centered design process kind of to a T as best as possible. So you're going in, you're doing contextual inquiries, observing people in their workflow, you're learning about their challenges, pain points, you're learning about the things that they really enjoy doing or that they derive some sort of benefit from, and you identify those as things that you should not be doing with a robot. That's just as important. It's just as important to understand what the robot should not do as it is to understand what it could do for someone to amplify them. So the beginning of the process, whether it's sort of B2B or straight to a consumer, is the same in my mind. There's a few kind of design principles, I guess, that I think apply to both settings, but are kind of magnified and a lot more important in the home setting. And they are kind of some of the reasons why I think successful home robots beyond a vacuuming robot, for example, are pretty far out there. So trust and transparency are really, really important with robotic systems. As a user, I want to know, what do I think? What do I think it's going to do, and does it actually do that, or does it do something totally different? Do I understand what its goals are? Do I understand how to change the privacy settings? Is the motion planning for the arm like super wacky and it's going like this, and why is that happening? Not every user needs that level of understanding, but you should be able to tell why it's behaving the way it is, so that it's not a black box. So trust and transparency, super important. It's obvious, but a need, can I tell that it is solving a real need, and do I have that need? Does it feel like this thing was designed with me in mind? Is it functional? Can it do what it says it's going to be able to do? The user experience, obviously very important. Again, was it clearly designed with me in mind? So if there's a graphical user interface, is it really thoughtfully laid out? Can I get to all of the privacy settings that I want to get to? Is there a way for me to teach it things if it's that sort of device? And also on robot, interactions? Are the communication modalities that the robot uses legible to me? The lights around the base of the robot turn green. Okay, what does that mean? If it's moving, do I understand the way it's moving, its path planning? Is it using sounds that are legible to me? Do I understand that this means, I ran into a problem and I need human intervention? All of these aspects of a robot need to be very thoughtfully designed from the very beginning of the process. And again, this is very important in a manufacturing setting, for example, but even more so in the home. And then another element is contextual awareness and sort of emotional intelligence. So let's say it's a home robot and it's like a weird, I don't know why I came up with this example in my mind, but I'm gonna go with it. Like I'm weeping on the floor for, I only do that like once a week, but I'm weeping on the floor. Does the robot know? Like it's probably not a good time to interrupt Steffi in her, catharsis and, ask about dinner or something. So can you, does it know, Steffi loves to have the house tidied, but can I teach it that it should not touch the urn on the mantle because that's really precious to me? Also a weird example. I promise I'm fine. Yeah. Can you teach it your preferences? And everyone has different preferences. Like something that's attached to your body, like an exoskeleton, there's definitely not one size fits all, and it's the same with robotic products that might end up in your home. So the home application, while it has very high impact potential, it's also extremely challenging. And I just want to put a plug in there. If you're doing a startup, hire at least one UX person, preferably a team, but yeah.
Awesome, thanks. So I think we have time to take some questions from the audience. So while you're thinking about your questions, let me just tell the panel I'm going to ask you two lightning questions at the end. The first one will be about, in terms of government regulation, should we be regulating the applications and not the technology itself, or should we regulate technology? So you can think about how you might want to answer that. And my other lightning question will be that many roboticists claim that robots will not or should not replace human workers, but rather augment. Like, what do you really think, based on what you know in your field and what you heard today? Are robots going to replace or augment in truth? So while you think about your answers to those lightning round questions, let's get some questions from the audience.
Hi, my name's Helen Nissenbaum. I'm visiting HAI from Cornell University, Cornell Tech, where I'm in the information science department. I think, I was on that side of the panel, Steve and Amy warning us of unintended, though potentially unsurprising consequences, and thinking about the socio-technical of it. And one of the things that I've seen time and again after going to many talks, including the ones today, is that we always hear, and this is fabulous, of the positive motivation for a particular technical product, and in this case, amazing advances in robotics. But there always are, at the same time, there's the potential abuses of this very same technology. And I mean, I teach this stuff, I'm aware of all these things. So we talk about, like, how do we make the technologists aware, or do we have to bring in, not only the UX people, but maybe hire an ethicist when you're doing your hiring, but how do we say to the technologist, you've been successful in motivating your work to the positive that whatever this thing is that you're building does, but also become astute to the potential downsides or the potential unintended but perhaps unsurprising consequences? Not to distribute this job to someone else, and I think undergrad teaching, exposing people, but to those folks who are actually producing the cutting edge research. Sorry if I went on too long, but thank you.
I understand. Would someone like to take that?
Do you want me to start? So what you've raised is such a crucial question, and it's something that corporations deal with a lot, and it's something intelligence agencies deal with a lot. How do we anticipate difficult to anticipate things? So I would say beyond the teaching, which I completely agree, we should be doing it early and we should be doing it collaboratively. There are two things that I think we should be thinking about. Number one, on an individual level, the most powerful question any leader can ask is, and what if we're wrong? That question alone invites a broader discussion to imagine possibilities the group hasn't thought about before, which leads me to my second. I study an analytic bias a lot. Right? We know that groups are better when they have multiple perspectives informing them. That's true in companies as it's true in agencies. So instead of having a devil's advocate that's appointed to red team, it would be better to have a genuine devil, someone who actually believes in the different point of view, and to create a culture where that dissent is valued. And that's how you avoid the groupthink that tends to lead you down a more dangerous path.
Steve?
I'll just quickly add, I think sometimes we do know of the negative consequences that are likely. It's just that the incentive structure is such that there's a penalty for us personally for pursuing, and there is an incentive to keep doing it. And so maybe we should rethink some of those incentives as a society.
I wanted to say thank you for each of the panelists having your remarkable comments and your insightful thoughts. The question, my name is Vince from the corporate venture team. So the question for you is that what is one thing which you strongly dislike or not satisfied in the current state of robotics?
I kind of said this, but I really feel like user experience has not played a big role in robotics so far. It's definitely happening more, but there's a huge opportunity to apply everything we know about the UX field and designing websites and apps to the design of robotic systems. There's so much opportunity there, and the UX is often totally deprioritized. It's like, okay, we have this robot, now make it look cool. And that's not what UX is. Certainly like, yeah, I want it to look cool, but I want to make sure it's solving a real need. I want to make sure it's, all the things I talked about. I think the two fields really need to come together a lot more. And I think oftentimes engineers don't take it seriously. They don't take user experience seriously. It's more like seen as the icing on the cake. And it's a lot more than that. So I think there's a lot to be done there. Yeah.
Steve, did you have?
Well, I'll just quickly add, I think our problem selection sometimes doesn't align well, I think, with many of our values, right? I think we're taking on the problems where we have the resources to pursue them, and which may not be the most important problems facing society. And it would be great to get better alignment of those things.
I really appreciated the emphasis on user-centered design and personalization. And one thought that came to me is that, my company started working, we worked with OT, occupational therapist. And I think I was really surprised at how well her skills in adapting technologies to an individual's needs transferred over to the robotic space. And I was kind of curious, are there other sort of professions like that where roboticists could benefit by working with them, maybe prosthetists? And so that was my question.
I think there's a lot to learn from demonstration by experts who are expert in interpreting what they're seeing and adapting a technology to a user. Some of the research in our lab has used robotic hardware where the adaptation process is mediated by a prosthetist, for example, with very positive results. So I think it's a great idea.
I think there's a lot to learn from caregivers, so professional caregivers or people who are not paid for the caregiving, and how they do their jobs, from an ergonomic perspective, how they make do when they don't have the equipment that you might have in, a facility or in a hospital. Human factors professionals related to OTs, but yeah.
Maybe I'll just comment that there's also sometimes kind of there's a technical arrogance, right? That there's a whole better, completely different way of doing something, which maybe does actually make sense technically. It makes sense on paper to completely revamp the way something is done currently. But those maybe technologies or startups will probably die before they actually get to be used because they won't be accepted. Sometimes you have to turn the ship kind of slowly in order to get to adoption. So I think there's always a balance between someone really having a revolutionary idea that might actually be better even than watching the way people do things now, but that often it just doesn't work because there's no way to get from point A to point B. All right, Londa, you.
Yeah, so I just wanted to, you're talking about the personalization. I think it's good if things can be customized. So there are the little robots for autistic kids. It's called RoboKint, and they can be ordered in 2 skin tones. It's all kind of binary, and two sexes, if you want to put it that way. But that means that there are more options, kind of off-the-shelf options for children for the type of robot they might like to interact with.
Can I follow up with a question for Amy related to this? So in the military or intelligence scenario, does there have to be this same kind of user acceptance, or can it just come down by fiat? This is the way we're going to do it. Does that mean that maybe we can be more risk-taking, I guess, with our technologies and do things differently than the way they're normally done? Or is it actually harder? I have no idea.
So I think, I'm really struck by the conversations I've heard today that the user experience being at the center of adoption and invention, and it's the same if you're looking at best practice for military capabilities, right? Do you need to know what the person on the battlefield actually needs, right? Are they ditching the unmanned system because it's too heavy and requires too much battery power, and they actually can't travel up a mountain with it, which is actually one of the cases that happened in Afghanistan. So understanding the user, whether it's a home healthcare aide, right, or whether it's a teacher, or whether it's a soldier, is crucial, and yet actually it's probably worse, I would argue, in defense than it is in other industries, because you have a small number of companies that do most of the provision of military equipment, and because there is such a disconnect between the user on the battlefield and what he or she may need. There are issues about gendered capabilities there too. Like, does the cockpit fit a woman or not? Is it designed for a man? Are the flight suits designed in the right way to accommodate different body types? I mean, all those things happen there too. And so there's been a real push in defense innovation to make the user experience the foundation and to build from there. But we're a long way to go to get there.
I just want to add one comment on that. At iRobot, we deployed 6,500 robots in Iraq and Afghanistan for roadside bombs. And the original interface was designed by an MIT engineer, and it had every possible thing you could do. In the field, totally unused. We put a Game Boy controller on it, and the engineer was outraged. But they can't do that. Yeah, but they can do 80% now instead of 0%. And it made a tremendous difference by putting a Game Boy controller on.
Yeah.
That's a great point. Thanks. So I think let's take one more question to the audience, and then we'll do our lightning round and wrap up the panel.
Hi, thank you for the opportunity. I'm Rainey, and I graduated last year from Learning Design Technology program at GSE. I was working for an AI agent startup as a UX research, and I totally agree with the importance of UX and all the innovation. But I'm kind of curious because in the current industry, all the iterations are extremely fast. But for UX research, especially for hardware, it's like either it takes a lot of time to take the qualitative interviews, or the iteration or the cost is going to be very high. So I'm wondering, in the current industry, how do we balance the rapid iteration and rapid research?
Yeah, that is a big problem. That's a really good question. So as much as I would like it, the engineering team is not going to wait at TRI while I do 3 months of research, right? They have to go. So you have to get creative with working in parallel and finding the right point where you overlap with the engineering team. And it most likely looks like maybe beefing up your prototyping skills. So maybe you can get away with clickable Figma prototypes, but you might need to start kind of hacking around with physical prototyping materials. Answer as much, learn as much as you can with these semi-functional prototypes, or do Wizard of Oz, where there's someone behind the curtain, driving the robot around, and just like do your best to kind of hack it. And it's kind of fun. Like it feels like you're breaking all the rules you learned, if you went to school for this, but it is the reality of working in industry. You can't, it's not, you got to work in parallel. But yeah, just getting as advanced as you need to with the prototyping, and maybe working with the engineering team to make a prototype that you can control, right? Something that you're able to drive. I'm assuming it's a robot, but whatever it is, making a minimally functional prototype. It's just the shell, so that you can answer some of the questions you need to, and then making sure that you're on the roadmap that they're on, right? So that it's not like, wait, we learned this thing, please implement that. You have to really be kind of in lockstep with their planning and talking a lot.
Thanks. Steve, did you want to chime in?
I agree with everything you just said. And always in this process, the user doesn't know everything that they want, or maybe they don't know very much about what they want at the beginning of the process, and you're trying to reveal that. I think it's especially challenging the more complex the interactions are with the person, and the more they depend on the actual robotic functionalities. Some things, as you were indicating, it's very hard to discover with very simple prototypes, and I love the Wizard of Oz model. That's fun.
Great, so let's wrap out the lightning round questions, and actually let's do this as audience participation as well. Let's have everyone vote, okay? So the first question, and feel free to get, this might be very far out of your comfort zone, but let's give it a try. So I've been trying to learn more recently about policy in my role as a science fellow at Hoover, and this is still a difficult question for me. But when you think about government regulation of robotics, or any technology that might influence robotics, including AI, the question is, do you think we should only regulate applications, or does the technology itself have to be regulated in some way? Okay? So let's just try a little straw vote. So who thinks that we should only regulate the applications? Raise your hand. Really? I almost expected the opposite. Okay, or maybe people are just not voting. Let's see. Who thinks that you should regulate some aspects of the technology itself?
Now I'm just going to take a little issue.
Sure.
So you said only in the first time.
Oh, I did. Sorry. Yeah.
So are we
sorry.
only on both? Or
Only regulate the applications, and then the second question is regulate technology, and then probably the applications
both.
as well.
Okay.
Yeah, the second part is both.
Right.
The fundamental technology
Sorry,
and the applications.
Thank you, Elsa, for clarifying.
So the second question is, technology and the application should be regulated. Okay. All right, interesting. Okay, so the other question is about the future of work, and much discussion today was about robots replacing or augmenting, but in terms of what will be economically viable for companies that make robots, and how they'll sell them and what they'll sell them for, the question is, do you really believe that these robots are going to collaborate and augment human workers, or do you believe they're going to be used to replace human workers?
I think you have to say what sector.
Yeah. Any sector that you want to think of. Let's just see where it goes. All right. So who thinks that robots will augment human workers more likely? Okay. And who thinks they will replace human workers more likely?
You think like all workers? I just don't think that's possible. That's not possible.
Yeah, you're right. It's not, but in terms of maybe percentages and a number of robots sold and what they do.
If only robots were that capable, I would hand over all my work to robots. But
That's true. But yeah, you want them to do not your creative work, but do the dishes and the stuff in the home. All right, well, hopefully this has been thought-provoking, getting all of these different perspectives on where we're going in terms of societal impacts. Let's give a round of applause to our great panelists.